The H-sync signal, or the horizontal synchronization signal, allowed us to move the electron beam or the scanning of the pixels from left to right across. So we need another one that actually goes from top to bottom, which we're going to call the vertical synchronization signal, or the V-sync. And it does it a little bit on the slower pace. And generally you want to go from the top to the bottom in 1/60 second, because we have a refresh rate of 60 Hertz. So let's see how does a vertical synchronization signal looks like. It's extremely similar to the H-sync. So the V-sync is also a digital periodic signal that goes between 0 to 1 logical, and it starts at 0, for example, in here, and then it's lasts all the way to 479, which tells me that this is basically 480, because remember I have 480 lines in the VGA resolution. And then at the very bottom, if you remember, we have like a screen and we have a border. So that border in here has the bottom border. So this one here between 479 all the way to 489, that's actually the bottom border, or what we call the front porch. It's actually 10. And then after those 10 in here, what it does, it actually goes and retrace all the way to the top, and that's basically a retrace, and it's pretty quick. It's actually 2. And then what you have is from the top, you will have another one here, which is basically the top border, and that's basically between 491 to all the way to 542. And this here is actually a periodic signal. So this one here is the top border because it's exactly the same as this particular period. So whatever you do here is exactly the same as in here. And that's how it is. In the V-sync, you'll see that it actually just basically a counter, and that counter goes from 0 all the way to that particular value, which is 524. So it's a 525 modular counter. And the period of this particular counter has to be, or actually it has to go from 0 all the way to that in 1/60. And this will guarantee, because remember, it's like the vertical synchronization signal is actually moving me from the first line to the last line, and it goes back. So it actually goes through the whole frame while the horizontal synchronization signal is actually going. So it's actually a single frame, and it has to basically do it every 1/60 second, because I have a 60 Hertz frequency, or the refresh rate of my screen. Similar to the H-sync signal, we have a video on signal for the vertical, and that tells me that it's only activated between this particular value and this particular value, which is actually between here and here. And that tells me that you should only display the value of the pixel when you're in between these two lines in here. Okay, and that just tells me where you should display the pixel, because remember, the borders shouldn't display anything, and during the retrace you shouldn't display anything either. A couple more notes in here. We started the 0 similar to the H-sync, because that particular value, we will also use it to indicate the Y direction in here, or the value of the Y for a certain or specific pixel, or the current active pixel. And also the another comment actually that applies to both the vertical and the horizontal synchronization signal is that these particular numbers, you might be wondering, where did they come from? The 10, the 2, and the 33. We know where this came from. It's actually from the VGA resolution. How about these 10, 2, and 33? And they're basically the size of the borders, and it seems that they're not symmetrical across the left border and the top border and the bottom border. They're not exactly the same. And that actually, for most monitors I've actually worked with, these numbers worked well. I've seen other monitor, for example, that doesn't do it as well, or you might need to change these numbers according to your monitor if you do see a black border across, or a black border on one of the sides. So you might need to change these. However, I did not need to change them so far.